Hi, welcome back. This is Professor Ridge, and today's lessons on section 2.2, the algebra of functions. It turns out that we can treat functions as algebraic expressions and add them, subtract them, multiply them, and divide them to create new functions. So we're going to start off with defining what does it mean to add two functions, to subtract them, to multiply them, and divide them. If f and g are functions and x is in the domain of both, then, okay, so that's key, that's important, that x is in both domains. So then what we mean by adding f and g together, we're going to add f of x plus g of x. We're going to take the y values for that given x value and add them together. So that's all it is. It's pretty simple. And it's the same for subtracting. F minus g of x is f of x minus g of x. F times g of x is f of x times g of x. And f divided by g of x is f of x divided by g of x, provided, of course, that g of x is not equal to 0. Okay, so let's find f plus g of x. So by definition, if we're going to add two functions, you're just going to add the y values for every x. So f of x plus g of x. And we defined f of x to be just 3x plus 5. That's f of x. And then g of x is the x squared minus 1. And now you're just going to simplify that using just your basic algebra rules. So combine like terms. 5 minus 1 is 4. Okay, so that's f plus g of x. You can do it with individual numbers too. So I might want to say, well, what's f times g of 3? And then you're going to apply the definition. Well, that's f of 3 times g of 3. So what we're going to do is figure out each of these separately and then multiply the result, the y value for both of them. So f of 3 is 3 times 3 plus 5. G of 3 is 3 squared minus 1. So f of 3 is 9 plus 5, which is 14. G of 3 is 9 plus 1, or minus 1, which is 8. And then you're just going to multiply 14 times 8. And I believe that's 112. Alright, let's try f divided by g of 2. So we're going to get f of 2 divided by g of 2. F of 2 is 3 times 2 plus 5. G of 2 is 2 squared minus 1. So that's 11 divided by 3. And that's my answer. Okay, so it's pretty straightforward. If you want to add, subtract, multiply, or divide two functions, then you just add, subtract, multiply, or divide the two y values. Domains of f plus g, f minus g, f times g, and f divided by g. Okay, so if we have two functions, if f and g are functions, the domain of the functions f plus g, f minus g, and f times g, so that's all of them, is the intersection of both domains. So another way you can think of it, it's the overlap the overlapping domain, or the what they have in common, right? What's common to both. Now the domain of f divided by g is the same thing. It's still the intersection of the domain, but you have to exclude any x values for which g of x is equal to 0. So let me write that down. Okay, let's try an example. Find the domain of f, g, f plus g, f minus g, f times g, and f divided by g. So if you recall, if it's a polynomial function or a linear equation like f, the domain is all real numbers. So pretty much we always start off with all real numbers, and then you throw out things that make it undefined. So that's negative infinity to infinity. Domain of g is the same thing. It's a parabola, so it's defined everywhere. And then the domain of f plus g, f minus g, and f times g is all the same. It's the overlap, what's in common to both. Well, since they both have all real numbers, this one's going to be all real numbers. And then the domain of f divided by g is going to be the same as the one we just did, but you got to throw out anything. You have to figure out when is x squared plus 5 equal to 0, and the answer is never, right? Because if you subtract 5, square root both sides, that's undefined. Well, it's an imaginary number. It's not real. So not real. So the domain is just the negative infinity to infinity. Now if we had f of x equals 2x minus 5, and g of x was x plus 3, then, okay, so the domain for f, g, f plus g, f minus g, f times g is all going to be negative infinity to infinity. So I'm not going to write that. It's the same. F divided by g is going to be negative infinity to infinity, but you have to exclude where g of x is equal to 0. So that's x plus 3 is equal to 0, so x is equal to negative 3. So we're going to go from negative infinity to negative 3 union negative 3 to infinity, because we've got to exclude that single point. Now, if f of x was square root of x plus 5, and g of x is, say, x minus 1, now with the radical, with the square root, if you recall, the radicand to be defined, the radicand has to be positive. So the domain of f is a solution to x is plus 5 has to be greater than or equal to 0. So x has to be greater than or equal to negative 5. So that's negative infinity to negative 5. Oh, I'm sorry. It's going to be bracket negative 5 to infinity. Sorry. Okay, the domain of g is all real numbers. So that's negative infinity to infinity. Domain of f plus g, f minus g, and f times g is what they share in common, the overlap. Well, since g is all real numbers and f is just greater than negative 5, what's in common is going to be what's greater than negative 5, from negative 5 to infinity. Now the domain of f divided by g, we also, it's going to be the same, negative infinity to, or negative 5 to infinity, but you also have to throw out what makes g of x equal to 0. Well, that would be positive 1. So we have to throw out positive 1. So it's negative 5 to 1, union 1 to infinity. Okay? So that's how you do the domain. So looking at the graph, find the domain of f. So the domain of f is from 0 to 6. Domain of g is from 2 to 7. So the domain of f plus g is going to be what they share in common, so it's from 2 to 6. Okay, it's the overlap. Okay, find domain of f divided by g. So that's going to be, so I got to throw out everywhere g is 0, and if you notice, g crosses the x-axis at 6, so g of 6 is equal to 0, so you have to throw that one out, so it's going to be from 2 to 6 with a parenthesis there. Find domain. Now we could switch it around. There's nothing that says I can't do g divided by f. So where's g equal to 0? Well, it's equal to, where's f equal to 0? Well, it's equal to 0 at 2 and at 5. So I have to throw out 2 and 5 from my from 2 to 6. So it's from 2 to 5 union 5 to 6. What's g plus f of let's do g of 2. Well, by definition, that's g of 2 plus f of 2. Remember, it's the y value in the g function, so that's 3 plus 0 equals 3. Okay? Our next topic is the difference quotient. And before I talk about difference quotient, let's talk about slope. Find slope between 2 points. If you recall, if you want to find the slope between these 2 points, we're going to do rise over run, which is y2 minus y1. That gets you rise. Runs x2 minus x1. So that's traditionally the way we do it. Now, what we're going to do is we're going to make our fancy notation. Now, instead of calling it x1, y1, we're going to call this point x and f of x, and then x sub 2, this distance is going to be h units, so x sub 2 is going to be x plus h. Now if we're going to use function notation, instead of x1, y1, we're going to have, this is going to be x, f of x, and then this one will be x plus h, f of x plus h. So if I take the slope between these two new points, y2 is the f of x plus h, minus y1 is f of x, over x2 is now just the x plus h, minus x1 is just x. And then if you simplify that, we get f of x plus h minus f of x, and then the x's cancel on the bottom, you just get h. Now this is called the difference quotient, and it's nothing more than the slope formula, just disguised a little bit. So the difference quotient is the slope between those 2 points. So let's find the difference quotient. So again, we're just going to write it down. It's just going to be f of x plus h minus f of x over h. Now f of x plus h, you're going to plug in x plus h wherever you see the x. So f of x is 5x plus 1. Notice I put the parentheses there, but I'm not doing f of x, I'm doing f of x plus h. Minus f of x, which is 5x plus 1, all over h. So notice this is f of x plus h, and this is f of x. Now we're just going to simplify using our rules for simplifying algebraic expressions. So I'm going to distribute the 5 minus, I'm going to distribute the minus 1, so minus 5x minus 1. Now if you do this right, those f of x terms should always cancel out. So if you notice, you got 5x minus 5x cancel. The negative 1 cancels the positive 1, and we're left with 5h over h. And then the h's cancel, and you get 5. And that should make sense in this context that, hey, I just told you the difference quotient's the slope. In this equation, f of x equals 5x plus 1, that's a linear equation, and you know the slope is 5. So it makes sense that between any 2 points, the slope is going to be 5. So the difference quotient is going to be 5. All right, let's try a little harder one. Let's try f of x equals x cubed minus, say, 4x. So I'm going to do f of x plus h minus f of x over h. Now again, f of x plus h, I got x cubed minus 4x. I'm going to put in x plus h for both of those x's. Minus, you better put parentheses so you don't forget to distribute the minus sign. X cubed minus 4x, so that's your f of x, all over h. Now we're going to distribute. Now x plus h times x plus h times x plus h. You can check this yourself, but you're going to FOIL it, or if you know the shortcut formula, is x cubed plus 3x squared h plus 3xh squared plus h cubed. Distribute the 4, minus 4x minus 4h. Distribute the minus sign, minus x cubed plus 4x all over h. And again, remember, we're going to be able to cancel out the x cubed and the minus 4x. X cubed and the minus 4x. And then let's see, anything else cancel? Nope. So let's combine like terms. So we get 3x squared h plus 3x h squared plus h cubed minus 4h all over h. We We're going to now notice all the terms have an h in it, so you're going to factor out an h from all the terms on the top. So we got 3x squared plus 3xh plus h squared minus 4 all divided by h. So again, the h's are going to cancel. And then we're left with 3x squared plus 3xh plus h squared minus 4. And that is the difference quotient. So that concludes the lesson for 2.2. Go to my math lab, complete your exercises there, and I'll see you next time.